we'll see some note. Two pairs of straight line a1x square plus 2h1xy plus b1y square plus 2g1x plus 2f1y plus c1 equal to 0 and a2x square plus 2h2xy plus b2y square plus 2g2x plus 2f2y plus c2 equal to 0 are parallel, then a1 equal to a2, b1 equal to b2 and h1 equal to h2. Next problem. Show that the two pair of lines 3x square plus 8xy minus 3y square equal to 0 and 3x square plus 8xy minus 3y square plus 2x minus 4y minus 1 form a square. See, a given pair of lines 3x square plus 8xy minus 3y square equal to 0, that is 1, and 3x square plus 8xy minus 3y square plus 2x minus 4y plus 1 minus 1 equal to 0, that is second equation. See, check the second degree terms in both. First one 3x square plus 8xy minus 3y square. In the second one 3x square plus 8xy minus 3y square equal to 0. See, that means from the note both are parallel. Right, we know that condition for perpendicular pair of straight line ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 is a plus b equal to 0. So consider the first equation 3x square plus 8xy minus 3y square equal to 0. Here a is equal to 3, b is equal to minus 3. So a plus b equal to 3 minus 3 equal to 0. So each line in this pair are perpendicular, mutually perpendicular, right? And h1, if you want, then h1 is equal to 2h1 is equal to 8, h1 equal to 4. So a1 plus b1 equal to 0. Therefore the pair of straight lines in 1 are perpendicular, that is, that result is 3, right? Now consider the second equation. Here a2 is equal to 3, b2 is equal to minus 3, h2 is equal to 4 and 2g2 is equal to 2, therefore g2 is equal to 1 and 2f2 is equal to minus 4, f2 is equal to minus 2 and c2 is equal to minus 1. Here also a2 plus b2 equal to 0, therefore the pair of straight lines in 2 are perpendicular, that is result 4. Now a1 equal to a2, right, 3, and hence the pair of line 1 and 2 are parallel. So a1 a2 equal, right, and h1 h2 equal, b1 b2 equal. So therefore 1 and 2 are parallel, right? That is that result is equation 5. From 3, 4 and 5 the pair of lines 1 and 2 form a rectangle, because in each pair the both straight lines inside the pair, right, there are two lines represent the pair of straight line, a pair of straight line, right, equation. So in that, in each pair of lines, right, so both are mutually perpendicular to each other. So suppose in the first equation there are two lines, straight line, they are mutually perpendicular. In the second pair, right, second equation, there are two lines, right, they are also mutually perpendicular, and the first pair is parallel to second pair. That means the first pair of line which are mutually perpendicular, which is parallel to the second pair of line which are mutually perpendicular. So join both them, you will form a rectangle. That is what OACB. So x dash x axis, y dash y axis, O is the origin. So this is the pair 1, right? Then this is green one is second pair, right? See, this is the rectangle OABC. See, to find the separate line equation of 1 and 2, right, we are going to find the separate equation. So we are going to factorize them. So 3x square plus 9xy minus xy minus 3y square equal to 0, right, not xy, last term is minus 3y square, right? So typo error. So first two terms we are taking 3x outside, so we will get x plus 3y into 3x. In the second term we are taking minus y outside, So minus y into x plus 3y, because 3y square, that is right. So 3x minus y into x plus 3y equal to 0. So separate line equations are 3x minus y equal to 0 and x plus 3y equal to 0. So the line equation OA and OB are respectively, so we are taking 3x minus y equal to 0 OA, right, OA equation, and OB equation is x plus 3y equal to 0. Now we are going to second pair, 3x square plus 8xy minus 3y square plus 2x minus 4y minus 1 equal to 0. Now we are taking, we know the factors of the second degree terms, right? 3x square plus 8xy minus 3y square, it is already there in above, right? 3x minus y, x plus 3y. So this equation can be written as 3x square plus 8xy minus 3y square plus 2x minus 4y minus 1 can be written as, so we don't know the constant term, we are taking it as c1 and c2, so it will be 3x minus y plus c1 into x plus 3y plus c2. That is equation number 6. So 3x square left hand side as it is, so right hand side we are multiplying 3x square plus 9xy minus 3y square, then x term, first term 3x into c2, right, that is the x term, so 3c2, then c1 into x, you will get x term, so 3c2 plus c1 into x, then y term, in the first one, so we are having c1 constant term, then second term y term, so c1 into 3y, so 3c1, then first term that is y term minus y, second term c2, right, in the second bracket, so minus c2, 3c1 minus c2 into y, then constant term c1 plus c2, comparing both side to so x term 3c2 plus c1 equal to left hand side 2. Similarly, that is equation 7, and y term 3c1 minus c2, that is y coefficient on the right hand side, on the left hand side you are having minus 4, that is equation number 8, and c1 c2 constant term on the right hand side, on the left hand side you are having minus 1, that is equation number 9. Now we are going to solve 7 and 8, we are going to find the value of c1 and c2, then we will get the equation, separate equation, that is the idea. So 7 into 3, 9c2 plus 3c1 equal to 6, that is equation number 10. So we are going to find 10 minus 8, equation number 10 9c2, equation number 8 minus c2, right, so 9c2 minus, we are subtracting minus c2, c2 term, we are grouping c2 term and cn term accordingly directly, right, then c3c1, right, in the 10th equation c1 term, in the 8th equation you are having minus 3 minus c1, minus 3 c1, right, which is equal to 6 minus 4. So c1 term get cancelled, you will get 9c2 plus c2 is equal to 10. So 10 c2 is equal to 10, c2 is equal to 1. So put c2 is equal to 1 in 9, so c1 equal to minus 1. So therefore the separate equations are, so 3x minus y minus 1, first equation equal to 0, and x plus 3y plus 1 equal to 0. So these represent the equation BC, side BC and AC respectively. So the side line BC represented by 3x minus y minus 1 equal to 0. The side AC, that line, particular side line, is represented by x plus 3y plus 1 equal to 0. To prove OA CB is a square, it is enough to prove the length of side OA equal to OB, right, all sides, it is a rectangle, so side length should be equal, then it is a square. We know that length of the perpendicular from the origin 0 0 to the line ax plus by plus c equal to 0 is modulus c by root of a square plus b square. To find the length OA, the length of OA is equal to length of perpendicular from the origin O to the line AC, side AC, x plus 3y plus 1 equal to 0. So here A is equal to 1, B is equal to 3, C is equal to 1. So length of OA is equal to 1 by root of 3 square plus 1 square. So you will get 1 by root 10. That is equation number 11. So to find the length of OB, so length of OB is equal to length of perpendicular from the origin to the line BC. because that side, right? O is the origin, no? B is on BC, right? So that is why we are taking length of perpendicular, right? The origin O to the line BC, 3x minus y minus 1 equal to 0. So here A is equal to 3, B is equal to minus 1, C is equal to minus 1. So length of OB is equal to modulus minus 1 by root of 3 square minus 1 square, that is also 1 by root 10. That is equation number 12. So from 11 and 12, OA is equal to OB. Therefore, OABC is a OACB is a square. In another method, find the coordinate of the vertices of OABC. So we are going to find each and every vertices. First, to find C, we know the point of intersection of pair of straight line formula. What is HF minus BG by AB minus H square, comma GH minus AF by AB minus H square, right? So the point of intersection of the line 2 is, so we are substituting the values, right? So we will get minus 8 plus 3 by minus 9 minus 16, comma 4 plus 6 by 9 minus 9 minus 16. So you will get C, the point of intersection of these two pair, right? These two pair point of intersection. See, just to check the diagram, so you will get clearly, right? C is the point of intersection of the pair of straight line 2, right? So C is 1 by 5 comma minus 2 by 5. Similarly, O we know origin 0 comma 0, that is easy, right? Then we know that the separate equation of the line OA and OB are respectively 3x minus y equal to 0 and x plus 3y equal to 0, right? So BC and AC are 3x minus y minus 1 equal to 0 and x plus 3y plus 1 equal to 0, right? So to find B, point of intersection of 14 and 15, these two lines. So B is 3 by 10 comma minus 1 by 10, right? Point of intersection, just we are solving these two, right? We will get B, right? Next, to find A, point of intersection of 13 and 16, right? So we are solving 13 and 16. Put 3x minus y equal to 0 using that idea in x plus 3y plus 1 equal to 0. So solving these two equations, you will get the point of intersection, right? Then length of OA and length of OB is equal to length of AC, which is equal to length of BC is equal to 1 by root 10. You can easily find the length, that is using the distance formula, root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So you will get this one. Therefore the given pair of lines form a square. So just we are doing, right? You just solve this. You can easily solve point of intersection. You find the point of intersection, solve these equations, and then using the distance formula you find the length. You will get the values, right? Thanks.